Welcome to EDU World Space.
Okay, in this question there is an inclined surface, okay, at the angle that is theta equals to 37 degree here, and a mass of 2 kg, okay, that is at rest on the inclined plane, okay, is pulled up by the applying a constant force F, that is F is given 20 Newton parallel to incline, okay, and force act for 1 second, so T is given 1 second. And now part A of the question, show that the work done by the applied force does not exceed 40 joule, okay. So we can say here it is F, okay, so mg will be for the downward, so uh, the perpendicular component, it will be mg sin theta, okay, and it is going upward, so we can say it will going upward here, so it will going ma, okay, so resultant will be ma, that is equals to F minus mg sin theta, okay. So from here F will be ma plus mg sin theta, okay. Now we can find out a here, okay, we have to find out acceleration, so ma will be F minus mg sin theta. Now we will put values, okay, so ma, that is equals to F, that is given 20 Newton, minus mg, okay, m is 2 and as per the question g is 10 meter per second square, so it will be 20 sin theta, okay, and a will be 21 minus sin theta divided by m, okay. And now we will put the values, so sin 37 degree, that is 3 by 5, okay, it will be 21 minus 3 by 5 and divided by m, that is 2, okay. So when we solve, it will be 20 and 1 minus 3 by 5, that is 2 by 5, okay, 2 by 5 and 2 is already there, so 20 by 5, that is 4 meter per second square, okay. So this is the acceleration we got, okay. And now the distance covered, it will be s equals to ut plus half at square, okay. So u is initial velocity, that is 0 because it was in rest, so s will be half at square, okay. So now we will put values, so a, that is 4 meter per second square and time is given 1 second, so it will be 2 meter, okay. So the maximum work done, okay, it will be force multiplied by distance, okay. So force is 20 Newton multiplied by distance covered, that is 2 meter, so it will be 40 joule. So this is the answer of part A of this question, okay. And now we'll move on the part B. We have to find out the work done by the force of gravity in that 1 second if the work done by the applied force is 40 joule, okay. So this is the work is equals to 40 joule is given, okay. So and force is 20 Newton, so the distance, it will be work divided by force, that is 40 divided by 20, or we can say 2 meter, okay. So this is the distance, but we have to find out the perpendicular part of this because it is an incline, so h will be 2 sin 37, okay. So when we solve, it will be 2 multiplied by 3 by 5, or we can say 6 by 5, or it will be 1.2 meter, okay. Now the actual work done, that will be minus mgh, now minus m here, okay. So mass is given 2 kg, g is 10 and h, that is 1.2, so when we solve, it will be minus 24 joule. So this will be the answer of part B of this question. And now part C, we have to find out the kinetic energy of the block at instant the force cease to act, okay. So no problem, for kinetic energy, that is half mv square, it means we have to find out the velocity, final velocity v, so v is equals to u plus at, again u is 0, so v will be at, okay. So a is 4 meter per second square multiplied by t, that is 1 second, so it is 4 meter per second, okay. And now kinetic energy, that is half mv square, so it will be 1 by 2, mass is 2 kg multiplied by v square, that is 4 square, that is 16, so 2 will be cancelled out by 2 and it will be 16 joule, and this will be the answer of part C of this question. Thank you.